Hi, everyone. Welcome to another episode of Ask Dr. Nick. My name is Dr. Nick Schmielkoffer, and I work for the Neurologic Wellness Institute here in downtown Chicago. And today's episode, I want to talk about sleep and why is sleep so important for brain health. And so that's our question for today. And we all know we need to sleep. We all know that sleep is important for our health, and that when we don't get enough sleep, we feel groggy, we feel maybe irritable, our mood changes, maybe we get some anxiety, and we're just fatigued and we aren't as efficient during our day. And so for this reason, our number one priority should be getting enough sleep and getting high quality sleep. And so I want to talk about just a couple papers, and they're pretty basic on just what sleep is, the different stages of sleep, and then what actually goes on during sleep that is so important for our brains and our health and our longevity. And so let's just get right into it. And so we're going to go to this paper here. This first one is from 2015, and it is the neuroprotective aspects of sleep. And so we'll just kind of go through here. I just want to talk real quick about some of the major highlighted points here that I put out. Obviously, sleep has proven to improve memory recall, regulate metabolism, and reduce mental fatigue. They say a minimum of 7 hours daily is needed for proper cognitive and behavioral function. This is variable. We can talk about that at the end. When one sleeps, the brain reorganizes and recharges itself. It also removes toxic waste byproducts which have accumulated throughout the day. This is super important because during our day, we build up all of this waste from our cells. And the only way that we can kind of declog that area is to sleep and to allow those waste products to get out of our brain, and therefore we can work more efficiently the next day. The effects of sleep restriction, which is much more common occurrence, have the same effects as total sleep deprivation. That's important too, because sleep restriction can just be that you're getting a little bit less each night for a week or 2 weeks, and those toxic waste products just build up. And then when sleep is deprived, the active process of the glymphatic system. So the glymphatic system is just another route that we can remove waste from our brain. We have the cardiovascular system, which basically brings oxygen and nutrients into the brain. That's your arteries. And then we have the veins, which take away carbon dioxide, take away water, and some waste products as well. But then here we have this glymphatic system that also pulls down waste products from our brain. And that goes, it's just a different route. And this route is specifically important during sleep, or specifically highly used during sleep. And what it does is it really takes away those toxins. And so these toxins can be things that generally build up in neurodegenerative diseases like amyloid beta in Alzheimer's, and tau or Lewy bodies that occur in Parkinson's. And so really trying to get those out can really help our brain's longevity. So now let's go to this picture here. So this picture is just showing our stages of sleep, okay? And so we have stage 1, 2, 3, 4, and 5. Stage 1 through 4 are non-REM sleep. REM is rapid eye movement sleep. And so when that is occurring, basically our eyes are moving very rapidly. It's the last stage of sleep. I'll get there. But to start, we have this stage 1 of non-REM. And this is just a light sleep. It basically is that point where you're not truly sleeping yet, but you're kind of like so close, and it's like something can easily wake you up. So that's stage 1. Then moving to stage 2, where all of our eye movements stop, our muscle activity stops, our body temperature, heart rate starts really to drop. And then we move into stage 3. And stage 3 this is when true deep sleep begins. This is when we have delta brain waves. So delta waves are the slowest brainwave we have. We have delta, which is super slow, Then we have beta and gamma, which are super high. And so beta and gamma are kind of used throughout the day. Delta wave is this super slow wave sleep. It's just to kind of keep our brain oscillating at a good rhythm, but it's just a good rhythm that we are able to do these important functions in sleep that are taking out waste and helping us with our improving memory and cognition. And so these delta waves are starting, and this is when deep sleep happens. And then when we get to stage 4, we only have delta waves. So we kind of have theta waves here, which is slowing down. Then we move into delta waves. And then stage 4, we only have delta. And so again, this is deep sleep. This is when most of our memory is consolidating during this stage 4. If we get waken up during this time, this is where we can really feel groggy. So sometimes you feel like you just woke up on the wrong side of the bed, or you got a ton of sleep, but you just woke up at the wrong time. When you wake up in this time, you feel groggy and you just don't feel like you rested very well. And so this is an important thing. And then REM sleep is our last stage of sleep. And this is when we dream. This is when our body temperature and blood pressure are completely decreased. We have our paralysis of our limbs. So we can't move our body, but our eyes are moving really rapidly. What that means is that our brain is actually working. And our brain is starting to consolidate all of our memories that were happening during the day. And then we can also, by dreaming, we're not going to get too much into dreaming because we really don't know why we dream. It's still a very big theory. But this cycle happens about 4 to 5 times a night if you sleep about 8 hours. And so each cycle happens it's about 90 minutes for a cycle. And as you go through the night, this REM sleep gets a little bit longer and prolonged. But while the deeper sleep, stage 3 and stage 4, is longer more in the first third of the night. So that's why that first third of the night is so important for memory consolidation. And at the end, the REM sleep is more important for like you feeling restful. So that's that paper. Now we're going to go into a different one. So this is a really long paper. It's from 2014. It's called Sleep and the Price of Plasticity. So it basically is talking about how sleep is super important for us to have consolidation of memory, integration, comprehension. It is a very long paper, but we'll just talk about a couple pictures, a couple photographs or figures. And so just in the abstract here, sleep is what is needed. We need to sleep in order to basically restore all the energy that was lost during the day. And so this is the synaptic homeostasis hypothesis. It's basically that sleep is the price that we need to pay in order to have plasticity and neuroplasticity and memory build up. So while we're waking, we're strengthening connections throughout the brain, and this increases cellular needs for energy and supplies. We're getting a lot of blood flow there. 20% of our blood flow in our body goes to our brain, but our brain only uses about 4% of our energy of our body. And so we're getting tons of blood flow there, using tons of energy. But during sleep, spontaneous, sorry, I said that wrong. 20% of the blood flow is going there, 20% of our energy of our body, but the brain is only 4% of our body weight. And so really it just uses way more energy than the rest of our body in proportion. And so during sleep, spontaneous activity is going to renormalize basically these synaptic strengths and restore our homeostasis. Homeostasis is that balance we need. This is important for memory acquisition, consolidation, and integration. So let's go to that first picture. So here it is. Basically, when we are awake, we are increasing our synaptic strength. We are taking in a bunch of information from the world, and therefore all that world is then helping us learn. And so we have cellular level costs, system level costs. So cellular levels are into neuron. We need more energy, we need more supplies. There's more stress going on. The space around the neurons are actually shrinking because the cells are getting bigger. and they're using so much, we're starting to saturate out plasticity. Basically, we're making all these new connections. But at the same time, we don't really have the ability to then have good vigilance, cognition, and actually learning. We don't actually learn during the day. We're just building up all this possibility of connection, this possibility of learning. Then we go into sleep. And so in sleep, we actually decrease the synaptic strength. So we are making all these connections, but all these connections, we don't need all of them. We want the ones that have the most convergence. So for instance, you meet somebody new and that person also knows, 3 or 4 of your other friends, or knows some of your acquaintances, or reminds you of your grandma. And so you can put those all together, in those past memories and other conversion aspects, like, oh, this is Jim, and Jim works for, State Farm. And you can put those connections together, and that's what strengthens those connections. Then when you sleep, you want to take away some that aren't as good. Like, you don't need to remember, if you went to the store and got 4 things in the aisle, you don't need to remember, going by, the little boy down the road, or you don't need to remember going through the aisle and seeing rice when you didn't want rice. You don't need to remember those things. Your brain is taking those images in, but you don't need to remember them. And so we are actually going to decrease those. We're going to decrease plasticity in those areas. We're going to take away those connections and keep the ones that are strong. And so we're restoring energy, we're restoring supplies. The extracellular space actually expands again because all those toxins are taken away. We restore the vigilance, cognition, and learning. This is where the memory consolidation, integration occurs. So basically, sleep is us just keeping the connections that are strong that we made in the previous day. And then here, this is kind of what we just talked about. And so during the day, when we're awake, we're sampling, we're taking in all of this information, all this sensory information, from sounds to touches to what we see visually. And we're making all these synaptic connections. But the ones that are going to stay, the ones that are the strongest, the ones that are, when we learn something new, if we can bring it back to a memory or an emotion, we're going to learn it faster, learn it more. It's because we're making more connections. Because then when we go to sleep, what happens is we kind of disconnect our motor. We don't move. We don't really have any more sensory information coming in, because there's a part of the brain here called the locus coeruleus that is just, it's not working. It's not keeping us alert. And so really what we're doing is we're just sampling everything that we saw today. And we're sampling everything we saw that day, and we're comprehending it. We're bringing it together. We're taking what was converged and has the best synaptic strength, and we're keeping that, and we're taking down the synaptic down selection. We are getting rid of synapses that we no longer need, the ones that, they're not necessary. And so this is why sleep is so important, okay? So let's go back here. So basically, to summarize, sleep is super, super important for the brain and our brain health. It not only takes away waste and toxins that were built up throughout the day, so that we can kind of keep our brain level and in a good, efficient manner, so that the next day we are strong and not fatigued and not irritable. But at the same time, it also helps us with our memory consolidation. And it is super important that we sleep to hold on to memories. And if we don't, that's where we lose memories. And then, of course, like I said, we get into the problems of other mood issues or anxiety or just relative fatigue. And so, to summarize, I'm not going to go necessarily into a bunch of ways we can improve sleep, but ideally, you're getting at least 7 hours of sleep a night. Hopefully that is good quality sleep. But remember, we have different cycles, and you want to be able to wake up while you're in that stage 1 light sleep. If you wake up while you're in stage 4, you might feel groggy. That's just not good. There are different ways you can track sleep, and that might be beneficial because there might be some foods that you're eating at night that aren't really beneficial for your night of sleep. So either way, I want to do another video on different beneficial effects that we can use to help our sleep, and different ways that we can kind of biohack our sleep. But for right now, I just want to end with, I want you to prioritize your sleep. Sleeping is the most important thing that we can do for our brains and bodies. And so really go out there and prioritize sleep. So if you have any questions, please leave them below. Any comments, again, below. If you have any suggestions for future topics, I would love to hear them. So thank you again, and have a great day. Stay healthy.